Have you ever pulled up a map on your phone and just wondered, how does it know exactly where you are? I mean, how do you find one single spot on this huge spinning rock we call Earth? Well, today, we're going to pull back the curtain on this amazing, invisible grid that covers our entire planet. We're talking about the simple but honestly brilliant system of lines and numbers that lets us navigate literally everything. So let's dive right in.
All right, here's the plan. First, we'll tackle the big problem. Just how do you describe a location? Then we'll build the solution, piece by piece. We'll look at the north-south piece of the puzzle, which is latitude, and then the east-west piece, longitude. After that, we'll see how it all comes together to make this awesome global grid. And stick around, because for the grand finale, we'll uncover a wild secret, how this same grid is the reason we have time zones.
Okay, so let's jump right in with the big challenge. I'm talking about a puzzle that seriously stumped people for centuries.
I mean, really think about it. How on earth do you describe one specific spot on a giant spinning ball? Imagine you're out in the middle of the ocean or a huge desert. There are no street signs, no landmarks, nothing. Without a system, you are completely and totally lost. And it was this exact problem that kicked off the search for a truly brilliant universal solution.
So the first thing you need is a good model of the planet, right? And that's where the globe comes in. And here's a fun fact. Earth isn't a perfect sphere, it's actually a little squished at the poles and kind of bulges out in the middle. The globe shows us that. So think of this globe as our canvas. It's where we're going to solve this whole location puzzle.
Okay, to even start drawing a map on this globe, we need a starting point, some kind of reference. And the very first one is the Earth's axis. Now, it's totally imaginary, but picture this line going right through the center of the planet, connecting the North Pole to the South Pole. It's like the skewer that our planet spins on. And just like that, it gives us our first two super important fixed points, north and south.
All right, we've got our north and south poles locked in. So now we can tackle the first half of the problem. How far north or south is something? And for that, we need to talk about latitude.
Now, this right here, this is probably the most important line on the whole planet, the equator. It's this imaginary circle that just wraps around the middle of the Earth, slicing it perfectly into two halves, the northern hemisphere and the southern hemisphere. We call it 0 degrees latitude. This is our starting line. Everything is measured from here.
Okay, so starting from the equator, imagine drawing a bunch of circles that run parallel to it, going all the way up to the North Pole and all the way down to the South Pole. These are our parallels of latitude. Think of them like rungs on a ladder. They let us climb up or down the globe and measure exactly how far we are in degrees from 0 degrees at the equator all the way up to 90 degrees at the poles.
But here's the thing, just saying 20 degrees isn't enough, not even close. Take a look at this. Chandrapur in India and Belo Horizonte in Brazil, they're both at 20 degrees latitude. So what gives? Well, the crucial difference is one is 20 degrees north of the equator and the other is 20 degrees south. That one little letter, N or S, it changes everything. It puts them on completely different continents.
And get this, these imaginary lines, they have very, very real consequences. A place's latitude pretty much determines its climate. It's all about how much direct sunlight it gets. So you have the super hot torrid zone right near the equator, the much more moderate temperate zones in the middle, and then the frigid zones up near the poles, which are, well, you guessed it, frigid.
Okay, so we've totally cracked the north-south code. We're halfway there, but that's only half the map. Now we need to figure out the east-west problem. And to do that, we need to introduce our second coordinate, longitude.
And here's exactly why we need it. Check this out. The Tonga Islands and the Mauritius Islands, they are both on the exact same line of latitude, 20 degrees south, but one is in the Pacific Ocean and the other is in the Indian Ocean. So if I just told you go to 20 degrees south, you'd have no clue where to go. We're clearly missing a piece of the puzzle.
So the lines we use for east and west are called meridians of longitude, and they're totally different from latitude lines. Remember how latitudes were parallel circles? Well, longitudes are semicircles. They all run from the North Pole straight down to the South Pole. The best way to picture it? Think of an orange. The lines of latitude would be like slicing the orange into rings, while the lines of longitude are like pulling it apart into wedges. They all meet at the top and bottom.
This created a big problem, though. Unlike latitude, which has the equator as a natural middle line, all these longitude lines are basically the same. There's no natural starting point. So what did they do?
Well, they had a big meeting, and in 1884, countries from all over the world agreed that the line running through the Royal Observatory in Greenwich, London, would be our zero-degree line. We call it the prime meridian, and that became the official starting point for measuring everything east and west.
Okay, so now we have both pieces of the puzzle. We have our north-south lines, latitude, and our east-west lines, longitude. So what happens when we put them together? Well, this is it. This is the aha moment where it all just clicks. When you lay those latitude lines over the longitude lines, you get this, a grid, a beautiful, perfect network of intersecting lines covering the entire planet. And it works just like the graph paper you used in math class. Every single point where a latitude line crosses a longitude line, that marks one and only one exact spot on the surface of the Earth. And just like that, problem solved.
Let's look at a real-world example. Take the town of Dhubri in Assam, India. Where is it? Simple. You find the line for 26 degrees north latitude, and you find the line for 90 degrees east longitude. The exact point where they cross? That's Dhubri. With just those two numbers, you can pinpoint its location on the map. It's that precise.
But wait, there's more. Finding places on a map is just the beginning. This grid has a hidden superpower. Seriously, and it's something you and I use every single day, probably without even realizing it. It's all about telling time. And the way it works is actually pretty simple math. Check it out. The Earth spins one full circle, that's 360 degrees, in about 24 hours. Okay, so if you divide 360 by 24, what do you get? You get 15. That means for every hour that passes, the Earth rotates 15 degrees of longitude. And since our planet spins from west to east, the places to the east are always ahead in time, because they see the sun first.
So look at this. Let's say it's exactly 12 noon in Greenwich, right there on the prime meridian. Well, if you travel 15 degrees to the east, it's already 1 p.m. But at that exact same moment, if you go 15 degrees to the west, it's only 11 a.m. It's a simple, perfect rule. For every 15 degrees of longitude you move, the time changes by 1 hour. And this direct link between where you are east to west and what time it is, that's the whole reason we have time zones. To stop things from getting super confusing, big countries or regions just agree to use one standard time. So, for example, India's standard time is based on the line that's 82.5 degrees east of Greenwich. Do the math, and that puts Indian Standard Time exactly 5.5 hours ahead of Greenwich Mean Time, or GMT.
You see this play out in the real world constantly. Think about watching international sports. A big cricket match might start at a perfectly reasonable 2 p.m. in London. But because of that time difference, that means it's starting at 7:30 p.m. in India. That's the global grid system working, right there, coordinating everything from business meetings to our favorite sports all across the planet.
So let's end with this one last thought. This amazing grid system, latitude and longitude, it was invented centuries ago for sailors trying to find their way across oceans using the stars. And yet today, the GPS in your pocket that guides you anywhere you want to go, it uses the exact same ancient idea to find your location down to a matter of feet. It's this centuries-old concept that's powering our supermodern world. I mean, how cool is that?